And by the way, I love your government, and President Biden is doing a great job for the country. I've never seen such a great president in my life. Anything else I can say? And your politicians are all honest and don't take money and become millionaires. Not that that has ever happened, because I'm sure all your, actually, aren't one of your communist guys got 3 houses? Yeah,
I don't know, but I know they know you're lying now with that statement about politicians.
Okay. Well, good morning, everyone. I have no idea where my brain is today. We're going to continue working with the section we did yesterday. Essentially, we're going to find the slope of the tangent line using one or other of these formula. If you get a question and it says use this one, or it says use that one, then you really should do it, right? Because not only are they getting you to practice using a particular technique, they're probably giving you a clue to which one of the two requires the least amount of work. So you're going to make your life easier. And so that's kind of where we were yesterday. And a lot of the questions ask you for the slope of the, not slope, the equation of the tangent line. And here's the point slope equation that we use for those questions. So I'm just going to jump right in and pick a question at random just to get the ball rolling. Question 7, the function that we're going to use is that one. And the point is going to be called x equals a. So we're not going to be told x is 2 or x is 3 or it's a point 3 comma, whatever. You're just going to keep it general. Okay, it's got a square root. I told you yesterday, hopefully you can remember, although both these methods work, so it's not a biggie if you choose your own one, which of these two is likely to be the easier to work with when the function's got a square root in it? Is it the top one or the second one?
Marlon.
So let's go then. It's going to be top one. Put a little note around here. If you see a square root, I don't know how you describe a fraction, but if you see a square root or you see a fraction, use this one. And if you see your polynomials, probably should use that one. And I've said this, but I'll say it again. You can actually use either. All I'm doing is telling you the one that would be the least amount of work. So in this question, they didn't tell me which one to use. So that means I can pick either, and I'm going to pick this one because this one plays better with square root functions. So the slope of the tangent line M is the limit as x tends to a. F of x is that guy. F of a is that guy. So far, so good. Now, you notice the only difference between now and yesterday is yesterday that would be, you know, square root of 9 or something, right? Now, because it has a square root, we know that we're going to use what's called the conjugate method. So the conjugate is the same two guys, but with a plus. So there we go. So we now are going to find the limit as x tends to a. If you multiply these two together, you get 4x. If you multiply these two together, you get minus 4a, and the other two guys in the middle get killed off. So when you do this guy times his conjugate, it's the first guy squared, take away the second guy squared. And on the bottom, we have an x minus a and 2 square root of x plus 2a. Just looking good. I like the way it's looking right now. Now, normally at this point, you would be able to cancel this guy with somebody in the top, but occasionally you have to do a bit more work. Is there anything simple we can do on the top? Can I rewrite 4x minus 4a in a different way. Can you see anything with?
Pull out the 4.
I would look for common factors. It's a good thing to look for. And now we can cancel that guy with that guy. So we are now, the slope is equal to the limit as x tends to a of 4 over that guy. For some reason, I lost my little square root. There we are, gone back. Well, at this point, once you've done all the factoring and cancelling, you're left with a fraction, which is this one here. And we can now put x equals a into it. What you get is 4. Instead of 2 square root of x's, replace the x with a. You have that. And then you have to do style points. Make it as pretty as possible. Well, 2 square root of a's plus another 2 square root of a's gives me 4 square root of a's. Are we comfortable with that? 2 plus 2 gets you 4. Is there anything I can now do to simplify that fraction?
Cross out the 4s.
You have a 1 on the top. And so the answer is 1 over the square root of a, which is totally okay. Technically, I should rationalize the denominator. If I did, the answer would look like that. So this is good, that is good. I don't care what you like. Which means that we now know that if you have the curve 2 square root of x, and you want to find the slope of its tangent line at x equals a, the slope is just 1 over the square root of a. So that's question A done. And question B, they ask you for the equation of the tangent line at the point 4, 4. So what you've told me is that x is equal to 4. So you've told me a is equal to 4. That means the slope then is 1 over the square root of 4, right? 1 over square root of a, which is a half. So I now know that the slope of the tangent line at this point is a half. In fact, if you tell me any point, I want to just be able to use this formula and tell you what the slope of the tangent line is. And I don't need to keep doing this guy from scratch every time. So you see the advantage of finding the answer in a general way, right, as x equals a. The advantage of that is that now that you have a formula, can't you find the slope when it's 16, right? When x coordinate is 16, or when it's 1, or when it's 9, or when it's 100. Just plug it in here and you got it. Now they want the equation of the tangent line at this point. So I've got the slope. And I know the x1, y1. So it's y take away 4 is 1/2 x take away 4. All I'm doing here is distributing and adding 4 to both sides. And there is your equation. Now, if I had time, I would then go on to part C, but I'll just pretend that I have the answer. If you did the square root of 2 square root of x, it would look like that. If you found the point 4, 4, imagine it might be here. This tangent line would look something like this when you do it. Right. Touches the curve at the coordinates 4, 4. Perfect. Now, if you did this wrong, right? If you somehow got the slope wrong, or you manipulated that wrongly, what you would see instead would be something that doesn't work. It would be clearly off. So you'd have your square root like that, and your tangent line would look like that. You see it misses it, and that's a sign that you've done it wrong. Or it could cut through the thing, wouldn't that also be a sign that it's wrong? So you can use the original function along with the equation of the tangent line. If you see this picture, haven't you kind of proved to yourself that you did it right? If you see a picture that looks like this, haven't you said, ooh, I've screwed up somewhere? So you can use it as a check. Are we okay with this extra little bit where we now find the slope of the tangent line at A rather than at a specific value? We okay with that? Okay. Let's look at another one of those. What will we do? A polynomial? Yeah, let's do a polynomial. Same kind of question. And this is question 6. And the function we're going to do is 7 plus 5x squared, take away 2x cubed. And we're going to do it at x equals a. Now I could use this, or I could use this. Since this is a polynomial, use this one. Now you are going to see a really long, ugly question. I know right now it's going to be that. And when I'm doing it, you're going to be thinking, well, maybe we should have done this one. Can you trust me if you do this one, it's worse, right? It just is. Maybe not so much the manipulation, but the factoring is horrible. Boil down to this. Does anybody here know how to factor that? And the answer should be no, none of us know how to factor that, including me. And that's what you tend to get if you use that, at least on the top line. So can you see, you might get to that point, then you're going to say, well, how do I factor it? Because you're going to have to do factor and cancel. We're going to do this one using that one, and it will come out. So here goes. It's going to be the limit as h tends to 0 of f of a plus h, take away f of a all over h. Okay, this is going to be ridiculously ugly. Here goes. This is the function. A plus h replaces x, so you're going to get a 7. You're going to get 5 a plus h squared. Take away 2 lots of a plus h cubed. Are you comfortable about the x's being replaced by a plus h's? Then you're going to take away and put it in brackets for safety, because you're taking away the whole thing. 7 5a squared, take away 2a cubed, all over h. I think it's lived up to its promise of being really ugly. Would you agree? That is very, very ugly. It's going to get uglier before it gets better. Okay, forget about this for a minute. Taking away these guys is taking away a 7, take away a 5a squared, plus a 2a cubed. Right, taking away that guy, taking away a guy, taking away that guy. Now 7's easy. A plus h squared is going to give you an a squared, a 2ah plus an h squared. A plus h cubed is going to get you an a cubed, 3a squared h, 3a h squared, and an h cubed. Now I know that because I've done enough a plus h cubes in my life. That's what you get. If you were doing it from scratch, a plus h cubed means this times this times a third one. And you break it into chunks. You do those two first. And if you FOIL them out, you will eventually get that guy. And then you do a kind of FOIL rule, 1, 1, 1, 1, 1, 1. And if you do all of that, can you trust me, this is what you eventually get. So if you're wondering where all these a cubes and 3a squares came from, it was a plus h times these three. So you take the top guy and you multiply him, you multiply him, you multiply him. Then you take the h and you do the same 3, you collect all the like terms and you get that. That's something for you to check later. Okay, so it's going to be the limit as h tends to 0 of 7. 5a squared, 10ah, 5h squared. Take away 2a cubed, 6a squared h, take away as well, 6a h squared, take away 2h cubed, minus a 7, minus a 5a squared, plus a 2a cubed, all over h. Right, that is as ugly as it's going to get. It's now going to start getting nicer. This entire horrible mess is going to become eventually a lot nicer. So, do you see that plus 7 gets killed off by that guy? Do you see this negative 5a squared gets killed off by that guy? See this plus 2a cubed gets killed off by that guy. So now you're reducing the top line by 6 terms. So I have 10ah, I have a 5h squared, I have this term, and lastly, that term. What you do now, I hope you can see it, is do you notice at the top, you can pull out a common factor of h. Great. Each one of these contains at least an h. So I'll pull it out as a common factor. That gives me 10a, 5h, that guy, and that guy. Check it. 1h out, 1h out, 1h out, 1h out, 1h. I can now cancel those. And I'm now left with the limit as h tends to 0 of all of this stuff. 10a plus 5h, take away 6a squared, take away 6ah, and lastly, take away that guy. And we can pretty much just replace h's with zeros now. Let's see what we get. We get 10a plus 5 lots of nothing, take away 6a. 6 times a times nothing gets you nothing, and nothing squared gets you nothing. So after all that hard work, we now have the slope of the tangent line to this function at x equals a. So I would like to know in part B what the slope is at the point 110. Well, that's the x coordinate, and x coordinate is essentially the a value. So m is 10 lots of 1, take away 6 lots of 1 squared. I can tell you at that point, the slope of the tangent line is 4. Once you have this done, can't you find the slope of the tangent line at any value you like? You know, I want to know the slope of the tangent line when the x coordinate is 1,000,000. Well, that just means a is 1,000,000. I want to know the slope of the tangent line when x is 1.23456. Well, that's all I make a, 1.23456. Plug it in here, and we get our answer. And of course, you would almost certainly be asked to find the equation of a tangent line at that point. So y take away 10 is equal to 4, x take away 1. Distribute the 4 and add a 10. And there is the equation of the tangent line. So we've got a pretty cool method. I know that's ridiculously ugly looking, but if you put that to the side for a minute, we now have a method that will tell me the exact value of a tangent line to any basic curve that you're interested in. You know, any polynomial, any square root, any fraction. And we can find its value in a general way at x equals a. In this case, we got that. And once you know that, you can find slopes of tangent lines, equations of tangent lines. Now that's one heck of an ugly looking equation. I'm not going to do it using the top method. Can you just trust me that it is just impossible, essentially? Algebraically, it's very difficult, if not impossible. Any questions before I move on to another application of this process? Are we good? Right. Don't let the messiness of it scare you. I mean, once you've done a couple of them, they're a lot less scary than they might have looked the first time you've seen it. So we're going to look at applications now. And I guess the question is, why would I want to know the slope of a tangent line? What does it tell me that is useful? Well, you find that in a lot of questions involving distances or velocities, that slopes are useful. So imagine I gave you a formula, h, and h is the height of an object that's thrown into the air. And the formula for what is the height of the object after t seconds is 17t take away 1.86 t squared. So can you imagine this is time and this is the height of the object thrown in the air and it hits the ground, right? It would look like that. And if you put that into your calculator, that's what the curve would look like, right? So I would like to know its velocity at 1 second, at 2 seconds, at 10 seconds, whatever I particularly have been asked to do. So in the first question, we're going to find the velocity of this. It was a rock, I think, in the story. At t equals 1 second. So I want you to imagine that as them telling you that a equals 1. Now, I could use this formula, or I could use this formula, right? This is the guy we're dealing with. Top formula or bottom formula. And it should be dead easy because the red writing gives you a clue. But just to make sure you're listening, which one should you use in this situation?
Bottom formula.
Bottom, right? You see cubes, you see squares, you see polynomials. I know that last one looked ugly. You're just going to have to trust me, or you're going to have to try and use the top one in that previous question. And if you use that top one, you'll figure out pretty quickly that you shouldn't have used it, right? Because nothing nice happens. Right, this one's going to work. So we are going to do the limit as h tends to 0 of f of a plus h, take away f of a all over h. And that's going to get me the slope of the tangent line. But the slope of the tangent line is the velocity, because slope is rise over run, which is distance, is the difference in distance divided by the difference in time. And now what velocity is? The rate of change of position with time, right? So there is a direct connection between the slope of a tangent line and the velocity. They're the same number, they're the same thing. So this one's going to be the velocity. So I'm going to call it that rather than slope. And it's still going to be the same formula, of course, but at 1. So it's going to be the limit as h tends to 0. Well, 1 plus h becomes 17, 1 plus h. Take away a very ugly 1.86, 1 plus h squared, minus the value of the function, this guy here, at 1. Well, 17 take away that at 1, yeah, 17 take away 1.86, you get 15.14. What I'm going to be doing now is distributing all those pieces and then later on collecting like terms. So 17 times 1, 17 times h, take away, if you square that, you get that guy. Then you get this guy. .86 gets you that guy. 1.86 times that gets you 2. It's 2 carry 1, 7 carry 1, 3.72 h. And that guy times that guy gets you negative 1.86 h squared. Take away a 15.14. Okay, let's try and make it nice. If you take that number and that number and that number, something very nice happens. What do you think you get when you combine those 3 decimals? What do you get when you combine that, take away that, take away that? Yes, big fat 0.
0.
0. If you do not get 0, will you stop there and go back and look at where you screwed up? Because the number part is always going to be 0. Right, that's just the way math is. The number part in these polynomials is always 0. So if you don't get 0, go check it, right? Because you know you're wrong. Don't even try and do any more lines of work. And what's left over and I wish I'd thought a little bit more, because if I'd thought about it a little bit more, couldn't have added these 2 guys together. So I'll do it now. So it's going to be the limit as h tends to 0 of that guy, and that guy gets you 13.28h. Are we comfortable with where we got to right now? Now, when you do polynomials, not only do the numbers always cancel out, as they do here, but you also will end up with a line that looks very like this. All the terms have h's in them. And so you can now pull out h as a common factor. Which means you can cancel the h's. So you're now looking at that. And you can now plug in 0. And that guy, take away nothing, is that guy. And there is the velocity of that rock being thrown in the air after 1 second. So if you can imagine, that's where it is at the 1 second mark. This number, 13.28, is telling me that it's zooming upwards, right? Still going upwards at 17.8 or 13.28 meters per second. So far, so good. Now, they ask you to find the velocity at t equals a, which I'm not going to do, but won't it look very like this, but these ones will be a's. What I'm going to do instead is part C, which says when will the rock hit the ground? And then part D, what velocity will it hit the ground? Now, these formulas that we're been working with have been known for quite a long time. Newton, about 1680, 1690, somewhere around about that time, the guy that essentially solved the problem, along with Leibniz. They knew these, and these formulas were widespread. In their day, do you know that they were used for lots of purposes, but one of them was military. You fired cannonballs in those days, right? Big humping, big. And they wanted to know things like, if I fired it, where would it land, right? Would it hit the castle wall, or would it miss it, or would it overshoot the wall? You might want to know what velocity it hits, because if it hits with a big one, doesn't that mean that you're probably going to do some damage? And if it hits with a very small number, you know, a velocity that's small, it's not going to do so much damage. So can we imagine this rock being shot out of a cannon, and this is the pathway? Right. Let's find out when it hits the ground. So we are going to have to solve, when is its height 0? Isn't 0 hitting the ground? So we need to solve when is this equals 0. Now, don't make life hard for yourself. Always try and think easy ways of doing something. I could try and use the quadratic formula on things like this, because factoring them looks impossible, but it's not. Have you noticed that they contain a common factor of t? Now, isn't that a much easier factoring than, oh God, I'm never going to be able to factor that weird quadratic? We'll make things simple. Now, solutions are twofold. T equals 0. Yep, you're right. At 0, it was still in the cannon, right? It was on the ground. And the other one is when that is equal to 0. So if you subtract 17 from both sides, you get that. And then you go and divide both sides by that guy. And so basically I know it's going to be positive. So 17, 1.86. It's about, that is a really ugly number. So let me check something. I'll check the solution. We'll see what we get here. Come on. Oh, to 1 decimal place, it's 9.1. And the question actually is when we'll hit the ground to 1 decimal place. So, okay, so it's 9.1. Now I want to find what velocity. So essentially, I'm not going to do it now because of how ugly the number is, but can't we just go back to here, make that 1.9 and go through this entire process again, and you will get the velocity. And I'll tell you right now, because it's in front of me, it ends up being -17. And does that make sense? Well, when it hits the ground, isn't it going downwards? And downwards is negative velocity. So we know that one. Now, if I've now figured out why they have that guy. If I can go through all of this, but make t equals a, don't I just need to put in 9.1 for a, and I'll get this answer right away? And I won't need to do all this ugly work. If you can find the slope of the tangent line at t equals a, then you can actually use it for every question that comes after that. Oh God, time. Time for one more. Question 10. Your position, S, is given by 6 over t squared. And we are being asked to find its velocity, which is the same thing as finding its slope at t equals a. So instead of me saying v equals, I'm just going to do m equals, I'm going to do v equals. And since it's a fraction, okay, I guess I'm going to call this t, is going to be f of t take away f of a all over t take away a. So we're going to find the slope of the tangent line to this curve at a, or if you prefer, the velocity of this thing at a. It's the same formula. So this guy is going to be the limit as t tends to a of 6 over t squared, and f of a becomes 6 over a squared t take away a. Now, if you thought polynomials were ugly, fractions can very often be harder, not necessarily uglier, because that's not that big. But it's quite difficult to see where we should go next. So I'm going to use a trick that you should use whenever you get a fraction and the top or the bottom is itself a fraction. I'm going to multiply by a special version of 1. Now, if I just wanted rid of the t squared, wouldn't I multiply top and bottom by t squared? And if I just wanted to get rid of the a squared, wouldn't I multiply the top and bottom by a squared? But since I want rid of both of them, do you see that I multiply the top and bottom by t squared a squared? Right, so that's the strategy I'm going to use to make this prettier, right? Something we can work with. And here it goes. It's going to be the limit as t tends to a. I'm not going to do anything on the bottom except write them together. Now, if you take this fraction and you multiply it by that guy, you will get 6a squared. And if you take this fraction and multiply it by that guy, you get -6 t squared. Are you comfortable about these two multiplications and what you get left? Right. Let's show you at the side then. If you take 6 over t squared, which is the first one, and you multiply it by t squared a squared, if you prefer, put it over 1, can you see that they cancel and you're left with a 6a squared And that's what I got. Right, so that's what I'm doing here. Well, it's looking nice, small anyway, but not very obvious where we're going next. And let me tell you that in these questions, it's always the top that you do things to. You pretty much never do anything in the bottom, right? Leave them alone. But what am I going to do to 6a squared take away 6t squared? Can you see any factoring that I could do to 6a squared take away 6t squared?
Take out the 6.
I would do that. Oh, pen's gone. Good start. Do you recognize that a squared take away t squared is called a difference of two squares? That's what we call a squared minus t squared. And they can be factored, can't they? And a squared minus t squared can be factored as a take away t, a plus t. Are you comfortable about that? Well, we're darn close to having the answer that we need. But we still have a little bit more to do. Once the top is factored as much as it could be, the next step should be to cancel. And I'm looking for somebody in the top to cancel with somebody in the bottom, because they have to cancel, right? That's the way the process works. And you might say, there's nothing there. There's nobody in the top exactly like a guy in the bottom, which is true. But that doesn't mean I can't still cancel, because there is something that can cancel. What cancels t minus a? What on the top cancels t minus a?
If you cancel a minus t and t minus a, don't you get -1 instead of 1?
Yeah, so that's what I've done. Cancelled them and made the answer negative. Great. So what we're left with now is -6a plus t all over t squared a squared. So once you've factored it and cancelled it, you're going to be left with something like this. All you need to do now is simply replace the t with a and then make it look pretty. So it's going to be -6a plus a over, instead of t squared, a squared times a squared. A plus a is 2a. So that's -6 times 2a. And a squared times a squared is a to the 4. And these two guys get me -12a over a to the 4. And then I can cancel one of the a's. And bingo. We got it. So for, let's write it down. For this function here, if you want to know the velocity at t equals a, the velocity is -12 over a cubed. So I want to know the velocity when t equals 1. That's 12 over 1 cubed. It's -12. I want to know it when it's 2, right? 12 over 2 cubed. Well, that's 12 over 8, which is 3/2. So it'd be -3/2. I want to know it when it's 50. I'm not doing this one. 12 over 50 cubed, right? And whatever you get, stick a negative in front of it. Once we've done this hard work for a, can't we now get the velocity at any value we like by just replacing a by the time? So if the time is 2, replace it by 2. I'm trying to sell this to you. This process is a little bit harder but isn't it worthwhile, the benefit that you get, that once you've done it once, you can find the velocity at any given time t. And we are finished. So last name for attendance. If you don't see Izzy tomorrow, the FBI have picked her up. And if you don't see me tomorrow, I've buggered off to Scotland so the FBI don't pick me up. Izzy, you're stuck. At least I've got a country to escape to.
Yeah, you're right. Puerto Rico still belongs to the US, so I can't go too far.
Okay, bye-bye, everyone. I'll hang about for any questions.
Thank you.
You're welcome.
Thanks for getting me locked up.
It hasn't happened yet. Maybe they'll forget about you. Anyway, we could always say it was San Diego that put us up to it, can't we? So it's good to have a backup plan, so we'll blame him, right?
Nice, I like it. We're going with it.
We're going with it. Good.
Thank you.
You're welcome.
I had a question about the limits at infinity homework.
Mm-hmm. Which one?
So so I finished it,
Okay.
but from like 12 to 15 on it.
Hmm,
It seems
okay.
like there's an easier way to solve them.
There might be an easier way to find the answer, but you have to prove it. So the process you're doing is more the proof.
Okay.
Right? Because I can look at a lot of fractions and tell the answer is going to be 5/3 0 and infinity. Is that the kind of thing you're talking about?
Yeah, pretty much. It's just that with all of them, you just sort of look at the whatever has the highest, value. Like if it's x squared,
Mm-hmm.
you look at the two x squareds, you remove everything else, and then that's
Yep.
the infraction every
Yep.
time.
And that's perfectly correct. Now, there's some questions on the 17, 18, and 19, especially, where essentially all you're doing is saying, I know this guy is bigger than the other one. So you won't be doing any real proof. The ones that came earlier to that, now that I'm looking at it, do you know the one that had like 7x cubed plus 3 over 2x cubed minus 7, that kind of question?
Yeah.
Those ones you are expected to do some kind of algebra proof of them. Whereas the later ones are really just relative size. What I mean by that is I know x cubed is bigger than 2x, And so if it's x cubed take away 2x, the x cube's going to win. And an infinity cubed means the answer is infinite, right? Things like that. I know the relative size. So that's all you would be doing in a question like 17, 18, and 19. On the other, not 19, I'll take 19 is different. Do you know how you should approach 19 as a proof? You might be able to tell me the answer is going to be -1/7, which it is, but how you could prove it in 19. So it's the limit as x tends to infinity of this guy over this guy, right? Now I can look at that and say -1, 7, -1/7. But if I wanted to kind of do a more formal proof, I would divide top and bottom by e to the x. Like divide top and bottom by x cubed, right? That kind of thing.
Yeah.
Now this guy I'm going to call 1 over e to the x, take away 1. This guy I'm going to call 1 over e to the x plus 7. And then I'm going to do brute force. 1 over e to the infinity, take away 1. 1 over e to the infinity plus 7. And then my argument goes like this. E to the infinity is infinity, right? And 1 over infinity gets me 0. And 0 plus 7, and hey, bingo, there we go. You see, I've got a kind of formal way of proving that the answer is -1/7, rather than just saying I can tell looking that it's going to be -1/7.
Okay. Yeah, what I did is to make sure I still knew how to solve it, so I figured I would have to, is I just
You will.
sort of
In the
checked my
midterm, you will.
answer, right? Because, like,
Well, checking your answer, if I'm picking you up right, you just put in a number like 100 and found out what this divided
well,
by
what I
x.
mean is like I could tell it was gonna be in my case like 1/8, right?
Okay.
And so I just solved it, and if I got 1/8, I knew I was gonna be right.
Okay, did you solve it in a technique similar to this one?
Yeah.
Then you are bang on. That's exactly what
Right,
you
yeah.
could do.
Okay, so it's
It's
viewed as-
helpful to know the answer before you even prove it, because when they match up together, you know you're right.
Okay, so it's to do a proof, so I know how to solve it, basically.
Yes.
Okay.
So these are proofs that the answer is. Now, as we were talking about earlier, there were a couple of examples at 17 and 18 where there is no real proof, isn't it? Just I know this guy's bigger than that, and therefore that's my answer. You know, like x cubed minus 2x.
Yeah.
But with those exceptions, right? With exceptions are the ones that look like that, and all the other ones provable, right? By